previous video, we've discussed the summary of the chapter Real Numbers, and now we are going to discuss the previous year questions from the chapter. We'll begin with the first section, that is Fundamental Theorem of Arithmetic. The questions asked from this section are mostly for 1 mark. The first question we are going to discuss was asked in 2008 for 1 mark. Series details have been provided for your reference. The question is, complete the missing entries in the following factor tree. They've given us a factor tree and we have to find the missing entries. It's a 1 mark question. A factor tree is a diagrammic representation of the prime factorization of a number. This is the number being factorized and these are its factors. So to find the missing terms, all we have to do is find the product of their factors. So this number will be product of these two numbers and this number will be product of these two numbers. So unless you find this number, you can't find this number. So let's assume that the first number is x. So x is equal to product of 3 and 7, which is 21. And the second number, let us assume to be y. Y is the product of these two numbers. X we've already found as 21. So 2 and 21. The product of 2 and 21 is 42. So y is equal to 42. So we've been given a factor tree with 2 missing entries. To find the missing entries, we find the product of their factors. We first found x using the factors 3 and 7. Product of 3 and 7, which is 21. And then we found 42, which is the product of 2 and 21. The next one is a direct question from product of primes. It was asked in 2019. Series details have been provided for your reference. It's a 1 mark question. The question is, express 429 as a product of primes. And the question is for 1 mark. So we have to express the number 429 as product of primes or product of prime numbers. So how do we do this? Let's find the prime factors of 429 using prime factorization. So in prime factorization, we start with dividing the number by the first prime number, which is 2. As you can see, 429 is an odd number. So 2 will not divide 429. So let's move to the next prime number, which is 3. 3 1s are 3, 1 remainder, 12, 3 4s are 12, 3 3s are 9. So 3 will divide 429. 3 1s are 3, 3 4s are 12 and 3 3s are 9. Next, 1 4 3, 3 4s are 12, 23. So 3 will not divide 1 4 3. So let's move on to the next prime number, which is 5. The units digit does not have 0 or 5. So 5 will not divide the number 143. So let's move on to the next prime number, which is 7. 7 2s are 14 and then you'll have a 3 remainder. So again 7 will not divide 143. So let's move on to the next prime number, which is 11. 11 1s are 11, remainder 3, 33. 11 3s are 33. So 11 will divide 143. 11 1s are 11 and 11 3s are 33. So 13 is a prime number. So we've arrived at the prime factorization of 429, which is equal to 3 into 11 into 13. So the method used to find the product of primes for a number is prime factorization. We find all the prime factors of the number. The next question was also asked in 2019 for 1 mark. Series details have been provided for your reference. The question is, write the number of zeros in the end of a number whose prime factorization is 2 squared into 5 cubed into 3 squared into 17. It's a 1 mark question. So we've been given the prime factorization of a number and we have to find the number of zeros in the end of the number. So the number of zeros in the end of a number will also be the number of times 10 appears in its factorization. To understand this, let us take the example of the number 250. So 250 is 25 into 10. But 2500 is 25 into 10 square, or this is same as 10 into 10. So there are two tens appearing in its factorization. So the number of tens in the factorization is same as the number of zeros in the end of the number. Now let's consider the given factorization, which is 2 squared into 5 cube into 3 squared into 17. So now we have to find the number of times 10 appears in this factorization. So 2 squared into, let's split the 5 cube as 5 squared into 5 into 3 squared into 17. We've done this to find the number of tens. We've split 5 cube as 5 square and 5 because we already have 2 squared here, and we know that 2 into 5 is 10. So here we'll get 10 squared into 5 into 3 squared into 17. So we can see that there are two tens in the factorization. Therefore, the number of zeros is equal to 2. So the question is to find the number of zeros in the end of a number whose prime factorization is given. So we've seen that the number of zeros in the end will be equal to the number of times 10 appears in the factorization. So we simplified the given factorization to find the number of tens, and since number of tens is 2 here, the number of zeros in the end of the number is 2. So here we have covered questions from product of primes. In the next video, we'll be looking at questions on finding HCF and LCM using product of primes.